So the core mission that we are all aligned at Fiddler is to really build trust into AI. So if you think about the three main challenges that companies suffer today with respect to AI is, talent. It's very hard to hire great AI talent. Tools. Many teams don't have the right infrastructure and tools to do it right. And the third most important challenge is trust.
Put together this Explainable AI Summit to help educate machine learning practitioners like yourself on the challenges, approaches, and the solutions from industry experts. So machine learning operations, or ML ops as it's called, is now a rapidly growing area as enterprises move their models from the innovation labs, from pilots, into the real world. And with models becoming increasingly complex, explainable AI is actually becoming an inherent part of all the aspects of operationalization of the model, from training to validation to deployment and monitoring, especially in regulated industries.
We believe firmly that for AI to scale, it needs explainability, it needs this visibility and transparency. And so we are marching towards that mission.
I think explainable AI system does not mean explainable to the decision maker. That is like the minimum bar to clear, but I think the actual bar to clear is explainable to the person who the AI system acts on.
I think it's a fascinating opportunity to essentially increase the surface area of AI for different disciplines within an organization, and and make sure more people can make sense of all this. I mean, all the questions you're asking rely on the fact that people can even understand it, right?
Yep.
That to me is one of the most exciting parts of AI as a discipline, right? Is making people understand what actually is happening and why.
Yep.
And that informs part of that art as opposed to the science side that we were talking about earlier.
You and I know there's not a team in the world that can build software without bugs. And because of those bugs, people will inevitably try to exploit them, right? And if you think about that sentence, you unpack it in two dimensions. One of them is the system behavior, right? Like, does it have bugs? And then the second one is how people are using it. And I think that's really, the ways in which the way we look at the problem has to expand. We got to look at system behavior and misbehavior, and that's, for example, where explainable AI fits right in. But then we also got to look at, sometimes the system works perfectly fine, and the user hijacks it in some way.
Organizationally, I feel, why do we talk about this responsibility, right? Responsibility is because it's not only limited to machine learning researchers who are doing the research, or developers who are developing algorithms and building systems. It also matters to indirect users who have impact of the products that they are using, because ultimately they are really exposed to that treatment exhibited by the product.
The responsible and ethical, I would like to rephrase that as responsible and ethical use of AI, rather than AI itself being responsible or ethical. I think it's an important, especially when you're talking with more mainstream people who are interested or who are being impacted, as the framing is pretty important. So it starts and ends with the people, and with people with human agency, as well as accountability within that framework.
Responsible AI is really about ensuring that the behavior of a given AI system is consistent with a set of requirements. And again, my colleagues have mentioned some of them: fairness, privacy, and so forth.
And as the tools and best practices used to train machine learning models have matured over the past several years, there's been a shift toward focusing on streamlining operationalization of machine learning in a scalable and responsible manner. And in the true broad steps within operationalization are deployment and ongoing observation of production models. So this panel and discussion will focus on the need for AI observability and key considerations for adding observability to an organization's AI infrastructure stack.
Well, there's definitely been a shift towards operations with the rise of ML ops. A recent report gave the figure that 25% of the top 20 fastest growing GitHub projects in Q2 2020 concern ML infrastructure, tooling, and operations. And Google search has seen an uptick on this. Explainability and monitoring are really a key piece of this. Teams needed to monitor models throughout training, validation, and deployment. So really the whole life cycle.
ML monitoring and ability to drill down and explain stuff is sort of inextricably linked. And effective monitoring needs explainable AI monitoring. And so, and then the reason for that is it allows for fast detection of issues, fast resolution of issues. It also helps ML engineers develop a better intuition around which areas are worth spending more time and energy on. And while also, giving us complete visibility. And it finally helps folks develop a stronger appreciation toward the robust ML infrastructure stack. So I think, Fiddler's tool and explainable monitoring has really been kind of a game changer as it pertains to a step function improvement on how we monitor and react to challenges as we see in the marketplace.
Monitoring is important in general, but with machine learning specifically, we've seen, things will go wrong, right? Like you have to assume that things will go wrong, and your machine learning team will be under the gun to fix it quickly. And the problem is, so the two sides of this are looking at your data, understanding what's happening, and then figuring out why it's happening, right? So in your models, if you have a model that you can't interrogate, where you can't determine why the accuracy is dropping, that's a very stressful situation. So it's common in companies that are operational with machine learning that there's some Monday staff meeting where people are looking at metrics, and then the shit kind of flows downhill, and it goes all the way down to some machine learning engineer with their manager breathing over their neck saying, what's going on? Why is this dropping? And it's a stressful 24 hours or 36 hours until they debug it and resolve it. And we need better debugging tools. So I think this is why stuff like Fiddler is pretty exciting, because a lot of this is just done manually currently, and ad hoc, and it's very it's very difficult. There's like some notebooks flying around and emails. We really need to have benchmarks that we're looking at consistently and continuously.
When people think about responsible AI, I think sometimes they think about responsibility in the wrong sense of the word, where, or responsible in the sense of society or doing good. But in a different sense, I think that if companies think of it as, we are responsible for the outcomes of this model, somebody needs to be responsible for what happens here. I think that forces the issue of thinking about, exactly what we're talking about, of how do we have explanations, how do we have monitoring, how do we have things like that. Because if humans, you can build products and humans can make decisions that have bias without ML, but somebody's ultimately responsible for that and can be held accountable for that. Just because it's in an AI black box doesn't mean that nobody's responsible. Somebody still needs to be responsible.
Today, I think in certain areas of the modern market, you really can't compete if you don't have sort of a data-driven and thereby model-driven view of what's going on.
Yeah, ML/AI has already, been incorporated in various shapes and form in the banking industry. And of course, how much it's been incorporated is a bit of a function of two things in my view. The first is availability of large-scale data. The second is around regulatory concerns. And so wherever there are regulatory concerns around embracing ML/AI, we've seen a little bit of a lag in embracing such techniques. But now, with new explainability techniques and the fact that more and more people are getting comfortable with these explainability techniques, these regulatory concerns are not quite as difficult to mitigate today as they were, let's say, even 3 or 4 years back.
Bias is a critical piece of the puzzle when it comes to managing model risk in general. And as we rightly mentioned, machine learning models in particular just expand the risk of bias. So the approach that I use, regardless of the type of risk that I'm dealing with, is understanding, first of all, what do I know about the model that I'm dealing with? What is unclear, and what are the controls around that complexity, the piece that is unclear. And that helps shape the framework or process or procedure that needs to be leveraged to mitigate the risk. So if you think of models as being black box, right? You have what's coming into the model, you have what's coming outside of the model, and then you have that black box that you can poke into from an explainability perspective to get a sense of what's going on in the model.
The purpose of model validation is not to prove that the model is correct in the sense of a principle of physics, because no models are really correct, and particularly in finance. What validation does is decide, is this model adequate for its intended purpose? Not even the best model. Is it sufficient for purpose? As George Box put it in a famous statement, the real question is not is the model correct, but is it so wrong that it's no longer useful? And that should be a mantra for everybody working in validation.
There's a gap, in my opinion, and I'd love to hear if the other panelists agree, but we probably don't have time. Incident response is not addressed in SR 11.7. I mean, if on a close reading, it says have contingency plans, but then it moves on to the next paragraph. And so we prepare for planes to crash. We prepare for other computer systems to fail. We need to be preparing for machine learning and AI systems to fail because they can fail in complex and unpredictable ways.
For example, in finance, we often want to calibrate things. So let's say you want to calibrate a multi-agent simulator that would generate a realistic mid-price return time series to better understand market impact or better understand agents' intent or behavior. Then the question is, how do you make sure that the data which is generated in an interpretable way such that you can ensure, you can make sure that regulation is met.
And it's interesting because I believe this round of questioning started by mentioning perhaps the snafus. And I think snafus are actually an important part of it suggests feedback loops are starting to happen more frequently, where people are able to see algorithm behavior, map it against their own experience, and articulate, this isn't what I expected, this doesn't seem reasonable. And a good interpretability tool should make snafus less likely down the line when it's too late to correct. It should allow people along the way to have the same degree of intuition to be able to audit. And that, I believe, has to be centered on showing subsets of the data that are most relevant for that user.
Going from explanations to actionable insights, that's something I mentioned already. So, you have the heat maps or those sorts of visualizations that are very useful, but how do you map it to a quantifiable outcome? It could be a business outcome or simply improve the accuracy of the model.
And that's exactly where interpretability can do its best. We can literally learn from our models if we can interpret them. But the problem has been very difficult.
I believe that we have a moonshot moment to make social change around ethics in AI.